See, the problem is very simple. The problem we will call it as TSP problem. TSP problem using branch and bound. Branch and bound. So this is the problem we have right now. So in the traveling salesman problem, TSP is nothing but traveling salesman problem. So what is the problem? I will going to tell you. Please see, observe here. The problem is given n cities. Okay. So nothing but 5, 6 cities they have given. A salesman start a specified city. Nothing but he will going to take one city as a source city. Okay. So often called as a source. Suppose if I take cities like A. Okay. Uh, cities like B, again cities like C, again cities like D, like this. So you will going to start from here. Okay, path will be like this. Like this. Path will be like this. Okay, any one vertex, any one vertex you will going to consider as a source vertex. So that is the meaning here. Often called as source. Visit all n minus cities only once and return the city from the where he started. Nothing but if he started from the A, he has to visit C, he has to visit D, he has to visit B again, he has to visit A again. So that is the rule we have to play here. Okay. So wherever you will going to start from there. Okay. So you have to visit all the cities like this. All the cities you have to visit. Again, after visiting all the cities, you have to come back here. So that is the rule. Okay. Fine. Objective, find a route through the cities that minimize the cost, thereby maximize the profit. Nothing but what is that cost of this particular road? You can see this one. Cost of this particular route we have to identify. So we have to identify the cost of this. So what kind of cost? Minimize cost, minimum cost we have to find out. Okay, minimized cost as well as minimum route we have to identify and we have to get the maximum profit. Okay, with that route we can able to get the maximum profit. That is the reason. Okay. Now model. What is this model is nothing but okay. The vertices of the graph represent the various cities. So this is what I showed you already. The weights associated with edges represent the distance between two cities. Nothing but this one A to C. This is the edge. Okay, that is the edge. Again, the cost involved from the one city to another city during the traveling. The observation in the constructing the state space tree. Already you know what is that state space tree. So like that we have to construct a state space tree. Tour always starts from A. Nothing but we will going to start from here. Okay, we will going to start from here. That is our tour. Okay, here we are starting from here. So let's say A. In the tour, first and last city remains the same. Okay, first and last city remains the same, nothing but so you will going to start from here again. You will going to come back here. So that is the reason why they are saying that first and last city remains the same, where other intermediate nodes be distinct and nothing but different. Okay, this is different. This is different. This is different. So this is the problem. Problem in one word. Problem is very simple. We are starting from A again. We are visiting all the vertices, nothing but all the cities. Again, we will come back to the same city, nothing but A here in this particular graph A. So that is the problem. In that, what we have to find out? We have to find out the cost, minimum cost and minimum route we have to find out. Again, we have to get the more profit in that. Okay, more profit we have to identify. So this is the problem definition. Okay. Now I will going to take the graphs here. I will going to take the graph. Okay. We will finish. Okay. As soon as possible. So graph looks like this. Please here. Graph looks like this. Something like this. A. Okay. Again, here I will take it as B. Again, I will take it as C here. Again, D here. Okay. Again, I will take E here. Fine. From A to C connection is there. A to C connection is there. So weight is 1. Again, A to B connection is there. Again, weight is 3. Again, B to D connection is there. That is 7. This is bidirectional. Okay, don't worry. Bidirectional that is. So this is 4. Again, just a minute. 4. Again, from B to C connection is there like this. Again, A to D connection is there like this. Okay. So this value is 6. Again, this value is 5. Again, from C to E connection is there. Again, D to E connection is there. Okay, this is 2. Again, this is 3. Fine. Okay. Again, one more connection you can see from wait. From E to A connection is there. So that is weight is 8. You take it as 8 here. Okay. Again, from E to B, one more connection. Okay. So this value is 9. So these are the things we have. Okay. Fine. So this is our current graph. You can see this. This is our graph. So we have a vertices. So that is A, B, C, D. So this is C. Okay. C, D, E. A to B connection is there. All connections are clear. Now what we have to find? Step 1. Please here. Step 1. Please observe here. Step 1. I'm talking about step 1. What we have to find out? We have to compute the lower bound. Okay. For this particular graph, generally what we have to compute? We have to compute the lower bound. Please write this. Compute lower bound. Lower bound value for the given graph. Okay. General lower bound. We will call it as general for this given graph. So we have to find the lower bound first. After that, so we're going to construct a state space tree. Okay. Now let's see this one. Let's see the graph. We have a graph here. So we have one formula. Please here we have one formula. What is this formula? Is nothing but okay. L okay. Lower bound is equal to okay S divided by 2. What is this? S is nothing but sum of two smallest distance edges. For example, see here, if I consider A, so you can see here A to B, again A to D, A to C, again A to E is there. So in this, we have to see the smallest edge. Okay. So in this, you can see 3 is there. Again, 5 is there, 1 is there, 8 is there. Which is the smallest one? Two smallest edges. That is 3 and 1. So that is what S is all about. S is nothing but sum of two smallest distance edges. So this one, this is the smallest distance edges from A to B, again A to C. Okay. These things we have to take it. That is the meaning. Understood? I think you people got it. Fine. Now we have to identify the lower bound. Please here we have to identify the lower bound. So that's why lower bound is equal to what we have to do. Let's say for the A we have to identify the lower bound. That's why A plus B plus C plus D plus E. Okay, na? So these are the lower bounds we have to identify first. Please understand here what is this A is nothing but so from A, please see here properly. You please observe here. A is nothing but so there are edges are from A to B. You can see from A to B. Again A to D is there. Again A to C is there. Again A to E is there. Okay. Sorry. So these are the edges we have. A to E is there. Okay, in this, please understanding everyone in this. Okay, these edges we have. In this, what we have to identify, we have to take the S value. Understanding everyone, we have to take the S value. S value is nothing but what? Sum of two smallest edges. Understanding sum of two smallest edges. That is the meaning. So that's why what I will going to do for A, please here for A. Okay, what are the smallest? A to B is there, again A to D is there, again A to C is there, again A to E is there, edge is there. So in this smallest sum of smallest two edges are, what is the two edges? One is 3, another one is 1. So that's why I will take 3, and 1. So why I'm taking 3 and 1? Because the reason is two smallest edges in that particular A. So from A, we can able to travel to B, from A we can able to travel to D, from A to C and A to E we can able to travel. It is a bidirectional, that is the reason. Okay, in that we are taking two edges which are smallest value. So that's why I taken this. Okay, B you take it, that is 3 plus 6. Why 3 plus 6? You can see this one. So B, from B to A, B to D, again B to C, again B to E. So two smallest edges are, what is that? One is 3, another one is 6. Again these two are 7 and 9, both are greater. That's why I will take 3 and 6. Like this I will going to take it. For C you check it. For C, here from C to A, C to B, C to D, again C to E. So what are the two smallest? 1 and 2. Okay, that one I will take it. So that's why 1 plus 2. So this is for A, this is for B, again this is for C. Okay, D also I will take it. Plus, what is the D? D value is, you can see here, from D, D to C, D to A, D to B, again D to E is there. What is the smallest you can see in this? 3 and 4. Okay, so this is the values we will want to take it. Okay, plus, again E value also I will take it. What is the T value? From E, you can see 9, again you can see 8, again 2 and 3 is there. Same thing, 2 plus 3. Two smallest edges we have to take it. Already I have taken. Guys, got it? Why I have taken all this? Sankit got it. Sanjay understood. Sanjay, Sanjana.
Yes, sir. Yes, sir. Understood. Yeah.
See why we
Yes,
are
sir.
taking two smallest edges.
Yes, sir, understood.
Okay, fine. So that is equal to, now calculate this one. What you will get? 3 plus 1, 4 you will get. Okay, again 9 you will get. 3 you will get. Again plus 7 you will get. Again plus 5 you will get. Okay, divide by 2. So this one. So that's why divide by 2. Okay, now. So that is equal to. So if you add this one, what you will get? 4 plus 9 plus 3 plus 7 plus 5. So that is 28 divided by 2. So that is equal to 14. Nothing but lower bound is equal to, okay, 14. So this is the first value, you got it for general, okay, lower bound value. Okay, now fine, everyone okay? These steps you understood, everybody? Srishti, Sanjay. Everyone understood
Yes, sir.
these steps,
Yes.
whatever I did. See, we have
Yes,
taken
sir.
general, okay, general lower bound we identified here for all the vertices. Okay, and we have taken, this is the formula. Please go through this formula. Okay, this is the formula. Okay, this is the formula. Sum of two smallest distance edges we have to take it. Okay, again that is divided by 2. Okay, that is what exactly I did here. And we will going to construct a state space tree. This is the 0th level or level 0. Understanding? This is the 0th level or level 0. Initial state space tree is starting now. Okay, so we will going to construct a state space tree. So that is here now. Please everyone observe here. So our state space tree looks like this. Okay, what is the value we got? Lower bound is equal to 14, right? So our state space tree, state space tree. So that is equal to, so what you will get initially like this. So this is our level 0. Please here level 0. So this one, whatever the things I am writing here, that is level 0. So we are starting here. Start, okay, lower bound, that is equal to 14. So this is the mean. So just we started. Okay. Now this is for general. When you see this graph, so generally we constructed a state space tree level 0. So that lower bound value is 14. And now we have to construct what is that lower bound values. Okay. For A, B, C, D, E, like that. For all the values, we have to construct. Just we constructed. Now from A to B, we have to select the path, right? So which is the path is better path? A to B, B to C, C to D, D to E, E to A, like that. Which is the best path we have to identify. That's why again we have to compute lower bounds for each and every vertex. How to do that one? I will show you one by one. We will finish. Okay, na? So this is done. This is also done. This is also done, and we will take one more page. Okay, now here we will going to compute the lower bound vertex A for A. Okay, so now we will going to compute. Okay, lower bound vertex from vertex A. Okay, na? So for A, we have to identify the lower bound. Now, whatever the things we have generated here, this is for general. Please understand general lower bound. So that is the reason why you can see the starting vertex is 14. Okay. So that is your starting vertex. Now we are computing for A. So now if I take A, please understand this one. If I take A, what happens? Basically, I will move from A to B. Okay. I will not take that graph. Just I will going to crop it and I will going to bring it here. What I will do, how to crop this one actually. I don't know. Wait. Okay. I know. Okay. Thank you. So this is our graph. Thank you. So like that only we can do. Okay. Thank you very much. Fine. Now what we'll do, we'll going to identify the lower bound. Okay. For A, we will going to identify the lower bound. We will see that one. What is going to happen? Okay. See here, A to B. Let's take from A to B. Please see here, A to B is nothing but what is that? A to B year, from year to year. See here, A to B, from year to year. Understanding? A to B. So what we have to do? Now we have to calculate the lower bound. We have to calculate the lower bound. That's why A plus, again B plus, C plus, and D plus E. Okay. So now we can see for A, what we have to do? First, so we have to see the vertices. See, from A to B is nothing but we have to look into this path we have to consider. We have to consider this path must we have to consider this one. That's why we have to write the 3 initially. Okay, for A, 3. Okay. A, this is A, this is B, this is C, this is D, again this is E. Okay, plus, 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 plus. Understood? Everyone understood? So why I'm taking this one? This path is must. Okay, from A to B I'm moving. So I'm going from A to B. I am traveling from A to B. So that is the reason why this path is must. Always this path is must. Again, another one. What is that minimum of this particular path? Okay, minimum we have to take it. I told you 2 vertices, minimum vertices, or 2 minimum edges. So in that one is there, one more. So that's why 1 here. In this also B. So from A to B we are moving. So that is the reason why when you go to the B, 6, 7, again 9, again 3 is there. But this path we have to include it. That's the reason why 3 here. Again, which is the minimum? That is 6. See why I am including both values here, 3 as well as 6 here, 3 and 3. Reason is very simple. I am traveling from, please understand here, I am traveling from A to B. Please here, I am traveling from A to B. That is the reason why this path is must. You have to include this one must in this particular values, S values. Okay, S values, you must include it. So that's the reason. Now fine, again C. So when you go to the C, so what is the minimum you are going to get it? 1 and 2. Same thing you write, 1 plus 2. Again, when you go to the D, what is the minimum you are going to get it? Actually 3 and 4. Same thing you write, 3 plus 4. Okay. Again, when you go to the E, what is the minimum? 2 plus 3. So the same thing, 2 plus 3. And calculate it now. So what is the value we're going to get it? 3 plus 1, 4 plus, okay, 9 plus 3 plus, again 7 plus, Okay, 5 divide by 2. So divide by 2. Okay, that is equal to 28 total. Okay, 28 divided by 2. That is equal to 4. Okay, 14. Your lower bound is equal to 14. Okay, so this is how we have to calculate. So initially I'm starting from what is that A to B. Now for generally we calculated from A to B we have to calculate. That's why from A to B you can see these values. Okay, for A, B, C, D, all these things when I do you will going to get the lower bound that is equal to 14. Okay, fine. Everyone okay or not? Kalyan, okay?
Yes, sir.
Okay, fine. I think you got it. After that, from A to B is fine. So again like this, A to B is fine. Again A to D, A to C, we have to find it. Okay. Again A to E. So all these things, A to C, we have to find everything. So that's why you will see here A to next one, we will go to A to C. Okay, here. Same thing. You have to understand this one. So A to C is nothing but what is that actually? This one. This root you must include it. This root you must include it. That is the reason why. 1. Okay, plus this is A. Please understand. Again A to C, right? Again plus B. This one is B. B. A. Plus C. Okay. Plus D. Plus E. So this the here plus. Okay, fine. Now see here, what we are doing, A to C, right? A to C must you have to include the one value first. Okay, A to C. Okay, after that, what is the minimum value? See here, you can see the what is the minimum value you can able to see. A to C is nothing but what is that? Minimum, we will going to have a 3, one more. Again, B, same thing. B means what is that? 3 and 6. Same thing you can follow. Sum of minimum 2 edges. Okay, in that. Again C, see here, when you see this one C, so A to C we are traveling, C we must include this particular edge. Please understand, we must include this particular edge. That is the reason why 1 year always. Plus now see here, so minimum in this C to B 6 is there, C to D 4 is there, C to E 2 is there. I will take 2. Okay na? Again D common thing. What is that? 4 and 3. 4 plus 3. Again E, what is that? 2 plus 3. So now calculate this one, what you will going to get it? 1 plus 3, 4. Again 9. Again 3. Again this one 7. Again that one will become 5. Okay, divide by 2. So this is divided by 2. Okay, so that is equal to 28 you will get divided by 2. That is equal to 14. So lower bound is equal to 40. This is the one. A to C we calculated. Okay, na? Everyone okay? These steps you understood or not? Guys, please tell me, these steps you understood or not?
Yes, sir.
Okay, fine. So like that, we have to calculate A to B is done. See here, like this. A to B is done. Again, A to C is done. Again, A to D, we have to do it. Again, A to E, we have to do it like this. A to D, we have to do. Again, A to E also we have to do. So that one we will going to do now. So we will going to finish it. Okay. A to D. Okay. So what we will do? Actually, we want graph, right? Okay. We will take that graph. We will crop it and we will take it. Fine, done. Now A to D, please see A to D. So what is the values? I will, okay, A to D. You please here, A to D. Please here from A to D here. You have to see this one, A to D. Okay, what is the value you have? So A to D, what is the value we have? Actually 5 is there. Please understand, actually 5 is there. This path we must include. Please understand, this path we have to include. Okay. So this path you should not miss it. That is the reason why 5 you have to take it first. Okay, 5 plus. Okay, what is the minimum for this? You see here, minimum is 1. Take it 1. Okay, A is over. B. Again, so what is that B? 3 and 6 are the minimum. 3 plus 6. Plus C. C you see here. C 1 and 2 is there. Okay, 1 plus 2. Again plus D. Now see here. That's what exactly I'm talking about. A to D is nothing but what is that? That path we have to take it. So that is the reason why 5 plus minimum you take it. What is the minimum in this actually? D means D to B 7 is there. D to A 5 is there already taken. D to C is 4. D to E is 3. That's why I will take it 3 plus E. Okay. So E is what exactly? Common thing. That is 2 plus 3. So because these two are minimum. Okay. But 8 and 9 are very high. So that's why. So finally what I will get? 5 plus 1, 6 plus 9 plus 3 plus again 8 plus 5 divided by 2. So what you will get? 31 by 2. That is equal to 16. Lower bound is equal to 16. Okay. This is the value we will get. So this is for A to D. Again, we will going to construct for A to E. So A to D is over. A to E we will going to construct like this. A to E. Okay, this one we have to take the path. So that's why if it is A to E is nothing but what happens here. Please understand. If it is A to E is nothing but what happens. Same thing. A2 is nothing and you must include that path 8 plus. Okay. So what is the minimum? A to E nothing but 1 is there. So take that 1 plus B. So B means what is that? 3 and 6 are the common. 3 plus 6. Okay. Again plus. Okay, fine. 1 minute. Fine. Again C. So C means what is that? Okay, 1 and 4 are the common. Okay, 1 and 4. Sorry, 1 and 2. Sorry, 1 and 2. 1 plus 2. Plus D. You check it D. D means 4 and 3. Okay, 4 and 3. Why that 4 and 3? Please tell me. So the reason is very simple because the two edges are minimum edges. See, when you see this one, D, 7 is there. Again, 5 is there. 4 is there. Again, 3 is there. Which is the minimum? 4 and 3. That's why I'm taking 4 and 3. Okay, A, B, C, D, E. E, you take it. Now, E, I said very clearly. So, from A to E, we are traveling. From A to E, we are traveling. That's why we must include one important edge, that is 8 plus 8 plus. Again, what is the minimum? Okay, minimum you take it. 2 is there, again 3 is there, again 9 is there. Which is the one? 2 is the minimum. So this is equal to. Okay, what happens here basically? So add this one, 8 plus 1, 9 plus again 3, 6, 9. 3 plus, okay, 7 plus again 10. Divide by 2 by 2 by 2. Okay, so that is equal to, what is that? 38 divided by 2. That is equal to 19. So lower bound is equal to 19. So already we did everything for each and every vertex. From A to B also we did it. A to C also we did it. Again A to D also we did it. Again A to E also we did it. Everything is done. Now, so go back to that state space tree. Please understand. You have to go back to that state space tree. Now you have to write it. Okay. What is that exactly? We have to write it from A to B. You can see now. What is that? A to B. What is the lower bound is 14. Okay, later. Why? Okay. See here, this one, we have to write it this one. What is that exactly? That is the state space tree. Okay, A to B have taken. You can see this one. Please see here. Where is that? This one. A to B, what is the value we got? 14. If I travel in that part. So that's why A to B, we are continuing the state space tree. So what is that? Lower bound is equal to 14. Again, we traveled from A to C, right? Yes or not? So A to C also we traveled. So that's why what is the lower bound? Lower bound is equal to how much we got? Check it. 14. Again 14. 14. Again we traveled from what is that? A to D. A to D. Okay, so what is the value we got it? That is equal to A to D 16. So that is lower bound is equal to 16. Again, one more. So we traveled from A to E. So what is the value we got? Lower bound is equal to 19. So these are the things we got it. So this is the state space tree. We did it. Okay. Guys, everybody got it? This one? Understood?
Yes, sir.
Okay, fine. See, now we have to take the minimum. Please understand this is very, very
So A
important.
to D is 15, sir.
A to D now.
Huh.
1
31 by 2.
A to D. See, 31. This one, Amma. We're talking about this one, right?
15, sir. 15.
Approximately we have taken the ceiling value. Correct?
Oh.
2 ones, again you will get 11, right?
Yes, sir.
2
5.
5 is a 10, okay, 10.5 you will get, right? Yes or not? 10.5 you will get it. Yes or not? So this is approximate value, that is 16. Okay, that's why I taken ceiling value.
Focus.
Ceiling value it is. Okay. So now, see here, everything is fine now. Now, what is this exactly? All these states where we got it. This is level 0, now level 1. This is equal to level 1. Now, see here. In this, we have to select the minimum because compared to 14, 16 is more. Don't select this one. Okay, don't select this one. This is also compared to 14, this is more. In this, you have to select these two. Okay. So, but see here, when you see this diagram, what is the diagram graph? So we have to, before moving to C, we have to visit the B, right? So that's why I will not going to select this one. I will going to select this one. Okay, from A to B, I will going to have a path. A to B, I will going to have a first path. So this is the first one. If you do this much, you will get the level 1. Okay, understood? Up to here, okay, na everybody. My question is very simple. Up to here, okay.